Hello, you're welcome back to my channel. Today we are going to be looking at another problem of indicial equation. And before we go into it, try to do well by subscribing, following, liking this channel to keep yourself updated. It is very important for the academia. So take note, if you want to make an indelible mark in mathematics, want to become the Chikobi that we know in mathematics, keep yourself updated in this channel. For those of you in the higher institution, you need this channel. Those of you in the secondary school, you need this channel. So take note. And how do you go about updating yourself? Is by sharing, subscribing, liking this channel, and following up. As you do that, you see yourself looking math as a no problem. So math will not be a problem to you. Hence, you are updated in this channel. I have brought math to your bedroom. At any time you want to have access to it, you can do. So now we are going to look at a problem, which we are going to look at it on the board here. We are asked to solve for t in 64 all over 29 is equals to 3 all over 4 in parentheses all over t minus 1. So when you have such a problem like this is an indicial equation. So what you need to do is, you say 64 all over 29 is equals to, now this is 3 all over 4 is raised to power t minus 1. In indices, when you have such a problem like this, what you need to do is this. If you have such a problem, just like you have, say, a t all over a, this is the same thing as saying a t minus 1, because this one have a power of 1. When it goes up here, it becomes minus 1. So now this case will now be like this. So here is the base, become 3 all over 4 raised to power t divided by 3 all over 4 raised to power 1. So you now see that anything raised to power 1 is that number. So in this case, we now cross multiply. This will go here, this will go this way. No, or you take this one this way. Since we are looking for t, take this way. You're now going to be having 64. You'll be having 64 all over 29 times 3 all over 4 is equals to 3 all over 4 raised to power t. So that is what you are going to have, having crossed this one this way. So now 4 here 1 time into 64 16 times. 3 here 1 time into 29 is 9 times. So you are going to have 16 times 1 is 16. 9 times 1 is 9. Is equals to 3 all over 4 raised to power t. So we are looking for t. That is what we are looking for. So in this case, you are going to be expressing both sides in powers to base 4 and 3. You are going to express, since here is 3 all over 4, you express both sides in powers to base 4 and 3. So you are going to be having 4 raised to power 2 all over 3 raised to power 2. So 4 times 4 is 16. 3 times 3 is 9. Is equals to 3 all over 4 raised to power t. So we have expressed both sides to the powers of base 4 and 3. So from there, we'll be having so from here now, this is the same thing as saying 4 all over 3 all raised to power 2, since they have the same power. is equals to 3 all over 4 raised to power t. So that is what you can see what we are having here. So in this case, we are going to be expressing the right hand side in power of minus 2. Why we are going to express the right hand side in power of minus 2. This is the left hand side. We are going to be expressing the left hand side in power of minus 2. Here is left, this side is right. So you'll be expressing the left hand side in power of minus 2. Why? So that they will have the same base. So when we express it in power of minus 2, when we introduce minus here, the base, the fractional base will now invert. That is, the denominator 3 will go up and the numerator come down. And if that is done, we are going to introduce minus, become minus 2 here. Is equals to 3 all over 4 raised to power t. So now you see the bases are the same. So when we have the base in mathematics, in indices, when the bases are when they have this equation with the same basis, so since the bases are the same, you equate the powers, equate powers. So you are going to have minus 2 is equals to t. So therefore, t is equals to minus 2. So this is the answer to this problem, as you can see here on the board. It's as simple as ABC. So you can see how simple this problem is. Follow the steps as I have done here. You see that it's very, very simple. Take your notebook and your pen, jot this thing out and solve this problem. You see that you enjoy mathematics. It's no problem. Just follow what I have done there. I think it will do you good. So we are going to look at the second example. So now this is the second example we are going to be looking at. So when you have such a problem like this, this is also an integral equation. You'll be expressing both sides of the equation in powers to base 3. So you now see that while we are expressing both sides, because 3 is the lowest base, so let us say we are going to express both sides in powers to base 3. So we are going to say, so 3 times 3 will give us 9. Here also 3 raised to power 4 will give us 81. That's 3 times 3 times 3 times 3. So will give us this all over 3x raised to power x. So we have expressed both sides of the equation in powers to base 3. So as you can see here on the board. So from this case, we know that this is multiplying everything here. That is to say, we are going to have 2 into 2x plus 1 is equals to 3 raised to power 4 into x minus 2 all over 3 raised to power x. So that is what this means. So from here, we are having 2 times, we are going to multiply everything inside this bracket by the number outside. We will now going to have 2 times 2x is 4x. 2 times 1 is 2. Is equals to, you do same here, 4 times x is 4x. 4 times minus 2 is minus 8 all over 3 raised to power x. And now see what we are having here. So from here, what you need to do in this case is since we have gotten this to be this, you need now to see how you can now express this quotient this thing. When you have the base like this, you subtract the powers. So we are going to be having 3 4x plus 2 now become 3 4x minus 8. This base, this power coming up become minus x. So from here, you now see that we are going to have 3 4x plus 2 is equals to, we now collect like time, 4x minus x become 3x minus become 3x minus 8. So we have gotten this equation this way. So you can now see that the bases are the same. So when the bases are the same, you equate the powers. Equate powers. Equate powers. So when you equate the powers, we are equating powers because the bases are the same. So we are going to have 4x plus 2 is equals to 3x minus 8. So we have equated the powers. So from here, you now see that you collect like terms because we are looking for x. So when you collect like terms, you are going to have 4x, this plus 3x crossing this, the sign of equality here, equal to here, it become minus 3x. Is equals to this minus 8, then plus 2 crosses become minus 2. So that is what we are having there. So from here, 4x minus 3x is 1x. Is equals to minus 8 minus 2. When you have a problem like this, which we have discussed in our previous lessons, minus 8 minus 2, you add the numbers but retain the minus. So when you add 2 to 8, you have 10. You retain the minus, become minus 10. So you can see that the answer to this question now, x is equals to minus 10. So you do well as you remain updated in this channel. Like I said, take your note, copy this, follow the steps like what we have done here. You will not find mathematics as a problem. So thank you as you watch me, and thank you for also remaining updated in this channel. You are welcome. So that is where we are going to draw the curtain today. So by tomorrow, we are going to see, I think, almost the last problem in integral equation. Then we'll get to the next topic. Thank you very much. If you have any question, go to my comment section and drop your comment. Answers will be given to you in the next lesson. Thank you very much. I love you all.